My name's Keith. I'm the author of PG Part Man. That's one of the other things I wrote. So recently, I'd written a script a little while ago, Python script for checking for Postgres bloat out, and it was using the Postgres, the bloat check that was in check Postgres. And for a while, it had seemed like it was kind of inaccurate to me. And the one thing that really kind of pushed it over the line was I deleted 300 million rows from a table, even after an analyze and a vacuum and everything. It was still saying that there was no bloat anywhere in the table. So something was wrong with it. So as an example, this is another table. This is what the check Postgres said was the bloat status of the table. Just 9%, 4 gigs of bloat, and on 3 of the indexes. What I found was there's another extension called pgstat-tuple, and basically what pgstat-tuple does is it actually goes through and does a full scan of the table. So it's slow, but it's 100% accurate from what I've been able to tell so far. This is what the result from pgstat-tuple said. So it's actually 16 gigs of bloat on the table, and there's all of the other indexes that were there, but that check Postgres said had no bloat. So it's a lot more accurate. So I redid the Python script using pgstat-tuple instead, and I lost my pointer.
Well, you keep moving it. It's over to so the screen is to the right.
Oh, okay, there we go. All right, so yeah, I did that. So you can see after I re-indexed the one index, now it's only 8 gigs. Again, indexes have, by default, some fill factor of about 10%. So indexes are never going to be completely bloat-free. I've updated my script to account for fill factor and stuff now. And so now some quick stuff on cleaning up bloat, just to show that it actually worked. Why isn't it? There we go. This is a graph. I don't know if you can kind of see over there. It says it's 1.4 terabytes, 1.2 terabytes. So you can see the biggest thing you need for cleaning up bloat is you need extra space. If you don't have enough space, you will not be able to clean up your bloat. I recommend if you are above 75% usage on your disk space, you are getting really, really close to not ever being able to clean up your bloat or having big problems. So you can see this is a graph of that same database where that group members table was. And you see the little increase there. That's when I created the new index before I went and dropped the old one, where you can see the little dip right there. And then I actually went and ran PG repack on the table to clean up all of the bloat on all the indexes and the table itself. You can see it went way up there in a big spike. That's about a 60 gigabyte spike, and then dropped down there. And then over the course of a few days, running using that script and seeing what the actual bloat in the table was, this ended up cleaning up about 280 gigabytes of bloat. And check Postgres was only seeing about 60 gigs of that. So this found an additional 200 gigs of space I was able to free up. On this database, it's about 1.2 terabytes. The scan takes about an hour to run. So this isn't something meant for real-time monitoring, but it does store the results in a local table, so you can just query that table in a monitoring script, and it won't actually run the whole thing again. So there's extra, there's just another example. This is actually reverse showing free space available. So you can see this customer had never actually been checking for bloat at all, ended up cleaning up generally about the same amount of space, about 300 gigs of bloat for them. The script has a bunch of extra options on it for saying you want to look for tables that are only wasting like 50 gigs of space and or 50% of the table is bloat. Same with indexes. Bloat isn't always a bad thing. There's the other. You can go to my website, keithf4.com. There's an explanation of what bloat is and why it's not always bad. So you actually don't want to be always aggressively cleaning up all the bloat. So there's extra options to this script to like say if there's you have a 50 gigabyte table and it's got 8 gigabytes of bloat, but that's a really, really small percentage. You just want to ignore that table unless that one table is over like 50% bloated. So there's a whole bunch of options for it like that. If you have any questions about bloat and all that kind of stuff, please check out my blog or come ask me. All right.
All right. So do we? You want to get up here and do this thing? 2, right? Ta-da.
All All right. Next up, we have Matthew Musgrave about migrating off of Sybase.
Got a lot to discuss, going to go really fast. So
Talk into the mic.
we have a legacy application, software as a service, built on Red Hat Linux, Apache, Sybase, Perl. It's roughly 275,000 lines of code. The queries within it are, most of them are hard-coded, but some of them are generated by an in-house function, and some go through DBIX class, also known as DBIC. Initially, this application was using Sybase's CTlib API with an in-house Perl wrapper around it, instead of the normal means with Perl of using DBI and, say, DBD Sybase. The table and column names are all mixed case, Pascal case, I guess you would say. And most of the queries were using comma joins with the funky asterisk equals and equal asterisk star joins that Sybase supports. No foreign keys whatsoever because that weird wrapper for accessing the database caused the application to segfault if you had a foreign key constraint violation. Also, because of no foreign keys, we had a lot of inconsistencies. So the same column across different tables was often a different data type. char 3, char 4, varchar 3, varchar 5, whatever. And Sybase supports roughly 40 different date formats, and we were using at least 6 of them in different places. And so development constraints, I was the only one allocated at 80%. Changing all the table and column names was deemed to be too risky because we'd have to touch everything. We did have some other developers who were working to convert to DBIC, but nobody was really allocated to do it full time. And then the final constraint, which was probably the worst of all, get it working as quickly as possible with the minimal amount of changes necessary and the minimal amount of upgrade time when it was time to go to production. So what did I actually do? Well, I switched this over to using DBI and DVD PG. The more complex queries, I went ahead and changed them to use ANSI joins if I couldn't convert it to DBIC. If going to DBIC was going to take too long, I just did a straight query change. I made all of the data types to be consistent across all the tables, fixed up all of those weird things. The identity columns, PKs, were all made to be integers instead of numeric whatever, comma 0. I altered the tables so that the small date times were date times, And all of those funky Sybase formats, I did away with them if at all possible. Everything is ISO dates, except in a couple of minor places. And how did I make this work? Well, I had to write some conversion code to fix the queries up on the fly because I couldn't touch all the things. So it's not perfect, but it works for our queries. I've tried throwing some, just on-the-fly queries at it, and it falls over. But, it did what we need. It converts all the function names from the Sybase to the Postgres names, and it quotes all of those identifiers so that we didn't have to do that in the code. Conversion process was pretty straightforward. Just dump it as SQL, import it on the other side. Dump it as CSV and import it on the other side. I did all of this in parallel as much as possible using the GNU parallel tool. Worked really well, made things go much faster than trying to do it in series. Testing is very important when you're doing something like this. You have to test the conversion process. You have to fix problems that come up. I had to do this in dev. I had to do this in stage before we could actually go to prod. Unit tests are great because they make changing queries a lot easier. Your unit tests will start failing if your queries are bad. It's very important to get all the stakeholders involved as early in the process as possible, get them testing with you, because they know how it's supposed to work better than you do a lot of the time. Regression testing also helps, and functional tests help fill the gaps. Here are all of my references in case you want to see them. We'll make this PDF available, and I'm going to stick around for a while if you want to talk to me about it any further. Thank you.
All right. Excellent. Okay. Next up, we have Greg Stark with some more slides from his talk this morning.
Oh,
Right?
that's not quite right.
That's not quite right. Okay. Another look at the elephant's tail.
Hi, so earlier today I presented a review of the last 20 years of Postgres and changes. One of the things I did to do that was, did some other talks at other conferences based on the same information, was I compiled Postgres from, since about 2001, 2002. I compiled many different revisions, including not just the major versions, but many different Git commits. And that gave me like a lot more data points, and I could demonstrate the changes that occurred at different points in time. And I learned some interesting things about the development process over the last 20 years. So first of all, obviously, I mean, this is a spreadsheet of all the tests. And I wanted to use modern tools, modern build environment, libraries, kernel, and do apples-to-apples comparisons on just the Postgres changes. So I didn't want to use old packages. I wanted to use the old source, but compile them myself, all in a similar environment. So I had to write a script, obviously, to automate this. These are all different Git check revision numbers at the top. The script tries to apply a collection of patches that I accumulated. So the process was basically going back a year or so until it didn't compile, figure out the problem, add a patch to the directory, go back another year, another problem. I ended up accumulating about 50 patches or so, most of which were back patches of later commits, but the causes of the problems were interesting. First of all, the world didn't stand still. All the tools had changed in the meantime. GCC had new optimizations that caused Postgres not to work right, new warnings, even complained about some of the syntax. Bison changed. It had new errors that it was much pickier about the syntax. Perl didn't, the configure script on the old versions of Postgres thought that Perl 5.10 was far too old because it required 5.3 or higher. So even sed was incompatible. libc had problems. And of course, I drew the line when I reached the versions of Postgres that didn't support 64-bit architectures. The most enlightening thing I discovered was that a number of, usually I would just find the later Git commit that fixed the problem and backpatch it, but sometimes I couldn't do that because, in fact, the problem had been fixed much later than the version I was running, or much earlier. It had been fixed because somebody foresaw the problem at a much earlier date. I couldn't find the Git commit because I couldn't just look at the date at which it stopped compiling. There's, for example, the ECPG parser. It was changed to generate its grammar from the normal grammar and just modify it using a script. That seemed to me a bit ambitious and risky at the time, and in fact, it did avoid a huge number of problems. I had to write a script to fix up the ECPG grammar to work with Bison, but Bisons that were much later than when it was actually addressed at the time. They removed varargs just to simplify the code. It turned out that compilers much later wouldn't have worked with the way we were using varargs. There's another change that I don't have time to explain. The release process was quite a bit different. This is a case of initdb just not working at all, and the response was, it's been like that for years, and I fixed it. I removed one character. Apparently sed was incompatible, like the new version of sed no longer handled the incorrect script. There was no talk of backpatching that or like finding out whether it was affecting users. It was just fixed, done. The collection of scripts, quite large. I still have almost a minute. Okay, good. I was trying to get to these slides. I did show them at my previous talk, but they really were the sort of a side thing. The time it takes to build Postgres using modern tools, the early versions of Postgres compile in about 45 seconds. Nowadays, it takes, with the same tools, it takes almost 3 minutes. And that's not because GCC got slower or anything else, it's because there's just that much more code to compile. And the code is perhaps a little more complex. It's been a pretty consistent increase over time, linear. It kind of looks like there's 2 data series. That's just an artifact because I was doing just an artifact of the way it was built. The binary size also has gone up pretty much linearly, though you can see some interesting fluctuations due to and a sudden increase at one point. And those have to do with the encoding tables. The install size, similar, though again the fluctuations are due to encoding tables. I think I'm out of time, and that's pretty much all I found.
Good job. Awesome.
Ooh, table size. Oh, it's the 20th birthday. Gotta include that. So it's 20th year of Postgres since it was open sourced. So pretty cool stuff. We like that. All right, yeah, woo. All right, what did you do, Greg? Whatever.
And I just use a left right arrow.
No, you can use this. Assuming I can get it back up.
Probably take me longer to figure out how to use this one.
4, right?
4,
Yeah.
yeah. There we go.
Where did it go?
Oh, no.
Oh, that was weird. Well, you can just use
I
that.
can look at that too.
You gotta talk in here, though.
Okay.
It should,
All right, next
can you
we
check, make sure
have-
the thing works? The clicker works?
Okay, yeah, make sure. What am I pointing at to make it work? Oops.
That. And then go back. Can I go back? It should work. Did it not work? Oh, well. Oh, this is the really big one. I forgot.
Ooh.
PDF Presenter Console got mad at, that's what it's taking forever to load
Oh,
because it's
Rendering.
24 megs and it's pre-rendering.
This is my first lightning talk ever,
Ouch.
so never threw this
Yay.
size aspect.
Oh,
I'll note
oh,
it.
and we're done.
ta-da, okay.
Okay.
There you
Next,
go.
we have-
Follow the time at the back, not
Okay.
this one. Okay, I'm shutting up.
Next, we have Debbie Serta with Postgres Community Survival and Fitness.
Okay. Thank you very much. So I'm going to talk about Postgres Community Survival and Fitness. Here's a slide about me. The important takeaways is basically my background for this topic. I have a Bachelor of Sciences in Ecology, Evolution, Conservation, Biology. I've been involved with data quite a bit. And if you really want to know how I got here, I have a blog post that's actually gone viral this week. It's a letter to my high school science teacher, so feel free to check that out. So we're going to talk a bit about looking at biodiversity and ecological systems and how that relates to Postgres and open source. The first thing to talk about is use sociality. And this is basically this very basic concept of having both a good or real society and being social. It's the highest level of animal sociality. And think about this in regards to what you do with Postgres. Cooperative brood care. Think about software, Postgres being your brood. Overlapping generations within a colony of adults. We have users in this room that may be using, that are new to Postgres or using different versions as well. Division of labor into specialized behavioral groups. We have people with different talents that are contributing to our community. If we look closer at this and think about social insects, they're a really just amazing, fascinating organisms. They have division of labor. They have communication between the individuals. They have the ability to solve very complex problems. Often that has to do with reproduction, food, foraging, and such. And colonies are often viewed as a superorganism because they're actually operating as a whole, as a unified entity, working together to support the colony itself. Now, you can't talk about social insects without E.O. Wilson. E.O. Wilson stated that field studies show that as biodiversity is reduced, so is the quality of the services provided by ecosystems. Records of stressed ecosystems also demonstrate that the descent can be unpredictably abrupt. We can't talk about E.O. Wilson without talking about ants. You have some Pogo Forester harvester ants that it's interesting. They actually gather plant material and such, yet they're one of the most toxic ants because it's a way that they avoid predation. So just because you're big and poisonous doesn't mean you're not have other resources available to you. And this image, of course, then takes us on to community. And the idea that everyone in here is part of our community. In fact, I go through this example, and what is out there as well that you can see is the Ecological Studies of Open Source Software Ecosystems project. I put the link here. You're welcome to check it out. But ideally what this is we're looking at what this does is they're taking complex systems modeling and they're using theories and models of biological ecosystems and comparing that to software ecosystems. Now we're talking about communities and ecosystems, but what's important is that it's not just about surviving, it's about thriving. I was very happy with Simon. I was really pleased to hear some of the things that Simon said today, and I can't help but quote what he said in regards to, I think about adaptation. And that what he said about Postgres is that to take ideas from lots of different sources and bring them together in one place is really the key to success. That nobody wants to use this product that's fixed in its ideas and unable to change. And that's what's important for adaptation, to thrive rather than just survive. Here's some examples, personally, that I've been involved with. I worked for a state agency. I was an accidental webmaster. We had a content management system called Byline when I first started that, for some reason, the agency decided to go with open source CMS. It was written in Java, but it was used in Europe, and there was no US community. The last update to that CMS was 2004, and no form activity since 2009. Plone is what the migration was to, has a strong presence, however, infrequent conferences and training opportunities. So you have a OS being used by a state agency, but there's no way to continue the growth and developers in that. And then WordPress, worldwide, it's a really amazing community. We have a strong community here in Texas. Over 53% of users are in the US. But as was mentioned today, it's MySQL dependency keeps it away from our world right now. Challenges to address in our community: onboarding new members, having inclusive content for users and developers at different stages of learning phases, what types of format of learning, knowing what those phases are, learning, and here's your community role. Simon's Postgres Challenge and mine. Sit next to someone you don't know in the session. Start now. Turn to the row behind you and introduce someone you don't know.
All right, thank
There
you
you
very much. Oh, thanks.
I love LightningTalks. They're so much fun. All right, here, I need to clear out some stuff here. Too many windows. There, much better. It's not your talk. We're getting there.
Number 5.
PDF presenter. We can do that.
There we go.
Pre-rendering, pre-rendering, pre-rendering.
Hold, please.
Hold, please.
All right, Sean Chittenden. I should stop talking. There we go. Yeah.
enough.
Postgres on ZFS.
All right, so this is a passion of mine, so to speak. It's not one that I get to talk about these days, but bear with me because it's a bit of a rant and it's a fun subject to discuss, having been through the trenches. So when you put bits on disk, hopefully the bits that you put on disk show up at a later date and come back to you in the original form that you put the bits back on are on disk, and we take that for granted. So some talks are meant to be provocative, and this is intended to be one of them, except for as you say some of these things, or I say some of these things about how maybe bits don't come back from disk, you want it to be FUD, but it's actually not. And in practice, we find that there really are bit rot and mutations, and we're talking about databases, and we put important information in databases, and for better or worse, we need to deal with the fact that bits do change, and a lot of us do care about this, but a lot of us also don't have to be aware of this because of cloud providers. Thank you very much for doing a lot of the bit correction that you do. But there's an entire generation of people that are unaware of bit rot because this has been something that's been slowly papered over by the cloud providers. And it's sitting there for us to deal with no matter what, and service providers deal with that for us, but people that run on bare metal need to deal with this by themselves. So if you're not using ZFS, effectively you're losing data if you're not in a cloud environment. And that's a scary statement, and I believe it. I said it. Other people have said it. This, from a math and probability perspective, should scare you because this is mathematically correct. So there have been lots of studies about this. I've recently dug into some of the research with regards to SSDs. In particular, SSDs are an interesting new media that has not had some of the history and robustness traits, I guess I would call it, added to them. So interesting things. I'm not going to get into what the paper says. There's this thing called an uncorrectable bit error, and there's a particular rate at which this phenomena happens. Bit errors happen all the time. Whether or not that is caught by the storage controller or the SSD is a function of probability effectively, and at a certain rate, uncorrectable bits will be presented back to the operating system if you read them and you detect them. That's not to be taken for granted. So there's some interesting bits in here. I'm going to call out the individual numbers. What that basically is getting at is not all SSDs were created equal. Some SSDs are better than others. The summary of that is, and this is a scary number, is that 4% of all SSDs will have one uncorrectable bit error per year, up to, depending on the manufacturer, 34% of your SSDs in a particular data center that's being used for actual workloads. And that's interesting if you think about how many SSDs do you have in your box, right? Do you have just one? Do you have 20? Okay, let's do some math here. 4% times 20, that means that in a given year, you're going to have a server with an 80% probability of having at least one bit flip, right? Okay, fine. So a single bit, maybe not that big of a deal. But depending on the media that you're using and the manufacturer, this ends up being a real big problem. How many boxes do you have in your data center? Are you in the single-digit boxes per data center or cloud environment, whatever? Or are you in the hundreds or thousands, right? This potentially becomes interesting because you've got thousands of boxes times many disks, and this becomes an interesting phenomenon or risk that you have to manage. And there's lots of things that contribute to that: temperature, bus, and write volume. Oh yeah, write volume. We're talking about databases and writing things to disks. So that write workload actually changes the reliability characteristics of the disks themselves. So in a data center, nobody can hear you scream. Not necessarily true. If you scream at your bits, they actually will pay attention to the fact that you're screaming at them, and they will actually come back and behave poorly for you. That's a latency graph. This was done at Sun once upon a time. So the gist of this is take care of your bits because your bits are doing work for you. So answer their cry for help. Okay, so back to ZFS and Postgres because this is really important. And by the way, I'm not just picking on SSDs. There are studies on this for all of the media that are out there, right? Fibre Channel SAS, doesn't matter, pick it, it's out there. They even exist for cloud object stories, and they do quite well, by the way. So I've written about this in the past. There's some interesting stuff there for adopting that in organizations. Postgres and ZFS, they were basically meant for each other. ZFS is a write-ahead log structured file system, not a block-oriented file system. The disk doesn't have to seek. So bit rot happens, it sucks, it's going to make you jaded and cranky. ZFS is really nice and fast. If you look at that, that's measured in nanoseconds, and look at that, that's 2.4 or 2 to 4 microseconds. Okay, it's fast, you can do a lot of volume there. That was done on 10,000 RPM SAS drives. You can do snapshots, you can roll back. That's nice and easy. It takes seconds. It's a big deal to be able to roll back quickly. You can get compression. It is a performance benefit on even SSDs to enable compression. Do it everywhere. Let's see, you get a win on compression. Send receive is awesome. Compressing or caching ARC records is important. It runs on Linux. Don't become jaded and cranky. There we go.
For my 2 cents, I don't think it's any coincidence that uncorrectable bit errors spells Uber. I assume we have more, right?
This is the last one.
We have the last one coming up, if I can get my screen to come back. It's not coming back. All right, we're just gonna do this.
That's how you know
We
it's awesome,
might have to win.
because it doesn't come back.
6, right?
Yes.
Ta-da! Never have I ever. So I'm going to introduce this because never have I ever. This is Gabrielle and Robert Treat. Let's do it.
Howdy. Oh, we're on the clock, so we should make this quick.
They already started. Okay.
They already did.
So this is a game.
Speaking to the mic.
What?
This is a game.
This is a game.
Everybody stand up.
Stand up.
So the premise of Never Have I Ever is someone will make a statement such as, never have I ever lost my hotel room key within 5 minutes of checking in. And anybody,
I see some of you already sitting down. Some of you already know how to play the game.
yes,
Yes.
anyone
That's
who
great.
has actually done that either subtracts a point or takes a drink or sits down, which is what we're doing today. So let's go ahead and advance it.
There you go.
Yes. Okay, we're going to play the database edition of Never Have I Ever. So, never have I ever tried to scale an access database for use over a WAN. And I would be sitting down right now. This is me.
See, a couple people sat down. All right, so you can see where this is going. And we're going to see how many of you have made the awesome life decisions that we have made over the course of our careers. So, for example, never have I ever installed Postgres when I was told to use some other database.
Oh.
Yeah. There you go. There you go.
New people have a distinct advantage in this game. Never have I ever run an app as the Postgres user.
Oh yeah, what's going on there? What about interfacing instance?
Okay, nobody's admitting to that
Well,
one.
yeah, luckily we're immune. We're immune to these. That's good.
Never have I ever run Postgres with Fsync off.
It's always good when a core team member sits down on that one. That's good. That's great. You see, like they're already down early, the core team guys. Like it's good. Never have I ever designed a schema with mixed case table names. Yeah, yeah, that's a good idea. We highly recommend that. You should totally do that.
Never have I
to code
ever
it all.
set autovacuum nap time to 1 day.
We don't know who tells people that this is a good idea, but if you're here, we want to know because this is not a good idea. We need to have a conversation with you. Never have I ever left auto-explain enabled over a long weekend.
Oh, I'd be sitting down again.
Whoops. Some people are like, I'd have to sit down more than once, I guess, on these, right? Yeah, don't do this either. This is also a bad idea.
Never have I ever left a trigger file in PG data after a failover.
We tried that. So I'm thinking we're mostly newbies left. I don't know. Oleg, I'm kind of wondering that. Yeah.
Staying strong.
All right. Never have I ever insisted on timestamp and not timestamp TZ.
Ooh.
Yeah.
Yeah, there we go.
If you're not sure why this is a bad idea,
Come talk
come find
to
us.
me.
We'll find. Yeah, there's some reading material you need to see.
Yes. Never have I ever made a restart required config change, so the next time the database crashes, I'm done.
I'd like to call this a best practice, but legally I am not allowed to. I don't know that this is necessarily a poor life choice. It's just, something some people do. Never have I ever used 9.6 on a production system. Well, this was kind of wonder. Like, it's still pretty early, I know. 9.6 isn't out yet, so good to see not too many people going down.
We usually get somebody with that one.
Yeah.
All right. Never have I ever used PL PHP in production.
Yeah, I have to go sit down. I've done that. By the way, if you ever see a system that's doing this, no, don't do that. I've done this, don't do this. It's bad. Never have ever just said, let the app handle the relational constraints. Okay, couple more. All right. And I know there's a few of you out here I know have done a couple of these X ones. I think you may already be sitting down. This is so unfortunate.
Never have I ever had a table with more than 1,000 columns.
Oh, I know that one.
Yeah, we
People left. We're doing all right here.
never have I had a schema with more than 1,000 tables. Yeah. I know. You only sit down one time. That's unfortunate.
Never have I ever agreed with this comment. If you do, yes.
Yeah.
All right.
Best way to cut down on the 1,000 column tables. Just replace 10 at a time with a single JSON column. If it doesn't get you far enough, you can just do it recursively again. It's great. I think this could get these last couple guys here. Let's see. Never have ever still running an 8x instance. No?
Okay.
I'm pretty sure NASB's run without Fsync on before.
I know, so it was hard to believe, hard to believe. Anyways, so if you want to find out more great ideas for Postgres, there's a talk coming up tomorrow, PostgreSQL worst practices. May or may not cover some of this material for you. Otherwise, next time you're at a bar or establishment, maybe in the next 30 seconds or so, where there's like some beverages going on, feel free to turn this into your own Postgres drinking game if you need to. Never have I ever done a Postgres drinking game with these kinds of things, though. I will say that. And with that, I will go sit down.
All right.
Thank